Hello, and welcome to AI in a Nuttyshell. I'm Florus, and in this video, we'll explore a neural network that has the amazing ability to transform game graphics into astonishingly realistic visuals. So, let's dive in and see how this groundbreaking technology works. Stay tuned. If you're interested in the process of creating graphics for games and films, aiming to achieve realism is quite challenging. The models must be meticulously sculpted, the textures must be intricately designed, and the reflections and shadows need to accurately represent the real world. A single flaw in any of these aspects is enough to shatter the illusion of reality. When it comes to simulating a real environment, one of the most difficult aspects is dealing with light propagation. Light scatters in multiple directions, reflecting off objects and mingling in intricate ways. The immense computing power required to accurately calculate these interactions is a significant challenge. However, creating realistic lighting in films is somewhat simpler. The software can be left idle for extended periods of time, continuously analyzing and rendering each frame. Once all the calculations are complete, the movie can be played. However, this approach does not work in gaming. In gaming, these calculations must occur in real time and be updated multiple times per second. The researchers contemplated this issue.
What if we cut corners? What if we ignore all these complex interactions and go straight to the end result? What if we put in a neural network to learn how to turn this into this?
And my friends, this is where it gets tricky. Nowadays, we have tons and tons of data available on the internet. In this data set, for example, we have images and videos of 50 real cities in Germany. And along with the images, there's also the segmentation of the objects. Segmentation is this colored filling that indicates the type of object that is in that pixel. That's where the idea came from. We're going to use the neural network to learn what the pixels of the cars and cities look like in this data set, and then use this learning to turn a GTA video into a photorealistic video. This game has an interesting advantage, which is that the scenery is based on real places in California. As the objects have realistic shapes, this makes it easier for the algorithm to learn. The question now is, can it work in California, given that it learned using images only from Germany? And the answer is yes. Look at this. The shape of the objects doesn't change that much, but the textures, it's bizarre. Look at the shine on the car's paintwork. It really looks like a filmed video and not a recording of a game. This level of detail is very difficult to achieve using traditional real-time rendering methods. The first thing we notice here is that the image has become a little greenish, a little desaturated. There are two reasons for this. The first is that games are exaggeratedly colorful and full of contrast to make them more visually interesting and grab your attention. The real world isn't that colorful. The second reason was the data set. The images used to train the neural network were filmed with a low-quality camera. The result, therefore, reflects this bias in the data. But the good news is that there isn't just one set of data. In fact, there are several. The researchers tested another set of data with higher quality images and greater contrast, and look at this. Look at that asphalt. And the grass. Now it is. Now it looks a lot like a real video. In the original graphic, the grass is just a 2D texture used to save processing. But not now. Now it really looks like it's made up of little plants. And the most impressive thing about this algorithm is its ability to generalize. The ability to apply photorealism to a city even by learning from the images of the other city. Imagine creating an entire game using footage from the real world. Images taken on professional cameras. Imagine the sense of reality. Now imagine technology like that in a horror game. There's just one detail. There's no point in this method generating realistic graphics, but not being efficient enough to do it in real time. So the question now is, can it run in real time? And the answer is, of course, yes, it can. This neural network is light enough to run in real time, and it can already be used as a post-processing stage. Human beings have already managed to create a virtual world within a real world, and now we're bringing the real world into the virtual one. In a few years' time, you might put on a pair of glasses, and everything will seem so real that it will feel as if you've been teleported to another place. And the question that remains is, considering two practically identical situations, but in one, you have costs and risk your life, and in the other you don't. Which one would you opt for? Which one would you choose? See you soon.